So hello everyone and welcome to an exclusive Fire by Live series panel discussion in collaboration with the International Water Mist Association. Today we are joined by four respected figures from across the water mist community, each bringing distinct insights and expertise from research and standards development to real-world project implementation and system design. And our aim today is to explore the unique advantages of water mist technology, its role in driving sustainability goals, and how it is evolving to meet modern fire protection challenges in sectors ranging from heritage sites to emerging battery technologies. So just before we start and get into the questions, I'd like to invite each of you to introduce yourselves and tell us a little bit about your involvement in the water mist community. So Markku, I'm going to kick off with you if you'd like to start.
Hello, my name is Markku Vuorisalo. I'm working with Marioff Corporation. I have been working in the industry 25 years in different roles: project management, business development, sales and marketing. And now last 9 years, I have been leading Marioff engineering. My background obviously is in engineering. I have been involved with IWMA roughly 9 years. I'm also a member of European Fire Sprinkler Network Council. 6 years I have been there. And yes, I'm happy to contribute to water mist industry in many different ways, I believe so.
Happy to do that. Thank you. And Dirk, we come to you next.
My name is Dirk Sprakel of Fogtec Fire Protection, and I'm with the company since almost 30 years. That's the time I'm involved in water mist. And I'm also serving in a variety of norming group guideline groups from NFPA to send the European ones, the German ones, and so on. I always enjoyed and was able to participate in many research projects carried out by Fogtec or by consortia with universities, test institutes, scientific institutes, and so on. And I'm quite internationally on the road around the world to make the world a little safer with water mist.
Thank you. And Dirk Laibach, we'll come to you as well.
Yes, my name is Dirk Laibach. I am also involved in water mist like my colleagues since many years, around 30 years. I'm working with around this technology. I am the global product manager for water mist, working for Johnson Controls International in this role now for 6 years. I'm also in the board of directors involved of the International Water Mist Association, also since about 5 years there. And I'm happy to contribute today with all my colleagues for this interview.
Thank you. And Robert, lastly but certainly not least.
Yes, my name is Robert Mostad. I'm from Rice Fire Research, independent testing and research laboratory. And I've been working here for about 10 years now, mainly with extinguishment systems, on particularly water mist. So that's my background.
Thank you, everyone. And it's interesting, obviously, all of you have phenomenal backgrounds and many years of experience in water mist. And it's very interesting in this topic because obviously water mist has been around for many years, and yet it's still treated almost like it's a new technology by industry. So it's something that we're going to look at the benefits and how it's actually not today. So first of all, I'm going to begin with the foundational perspective. So Dirk Sprakel, I'm going to come to you first. What makes water mist so special compared to other fire suppression technologies?
I mean, we really could simply say that it combines benefits of other technologies with each other by avoiding major disadvantages of other technologies. So what do I mean by that? First, I should add that the other technologies, they are not bad. Yeah, they also have their place in the market. Yes, but there's a vast variety of applications of risk which can be protected by water mist systems, because compared to sprinklers, so-called deluge systems, water mist systems only use a fraction of water, a very minimum amounts of water, and that means that the water damage is really minimum. You need only very small storage tanks, so they don't require a lot of space. The pipework is small and nice and elegant, can be nicely integrated into industrial complex systems or in a nice old heritage building, a 200-year-old, let's say, palazzo in Venice or whatever. So what the traditional sprinkler could not achieve in the same way. But we also, compared to a gas system, we don't require a completely sealed room. We are completely safe for people. So you don't need a pre-warning time. You must not worry about your workers or people from the public entering a data center or whatever. Yeah. So it's really, really safe. And what is maybe one of the most striking points nowadays is that it's a completely environmentally friendly technology. Not only that we avoid wasting water or contaminating water by reducing the amount of water, but we are also obviously avoiding to use chemical gases, for example, which would harm the ozone layer or things like that. We don't have any negative effects on animals, on plants, and so on. And there are many aspects in water mist supporting sustainability. That means you can, for example, that you can do nice retrofits. You don't have to take an old building down because of, let's say, fire protection concerns. The water mist technology, for the first time, more or less, allows you to cost effectively upgrade old existing buildings, which already have anticipated the energy to build it and so on. Here you can now upgrade that with water mist to give it another 30-year lifespan. So there are many aspects in regard of environmentally the sound aspects as well as sustainability, which makes water mist so interesting for our society nowadays.
Absolutely. And you mentioned a lot of points that we're going to delve into in a little bit more depth in this panel discussion. But obviously, you listed a lot of benefits there. So why do you think that it's often a somewhat misunderstood technology or system today?
It was in the beginning for many fire protection people really, really difficult to accept that less water can have a much better effect. Yes. And we all think naturally, yes, that if we would have a fire at home in the garden or whatever, the more water you pour on it, the better it is. Yes, but it can be much, much better when you use only fractions of this amount of water with tiny little droplets, creating a huge surface on the water. Yes, to extract the heat, the small droplets, the very small droplets, being able to take out smoke particles, to wash out acids from the smoke and so on. So the small droplets can work so much better than big droplets and huge amounts of water. And that was really, really difficult for a lot of people in the fire protection industry to understand. And I can well understand that they didn't understand, because it's really against something which we were learning maybe for the last 1,000 years. And that meant that there was a lot of skepticism in the industry. And also we have to acknowledge that all the companies which went into water mist, they came all from outside the fire protection industry. These were not companies working in fire protection since 200 years. So they first had to gain their acceptance.
Thank you. And we're going to come on to our kind of first part of the session. And it's going to cover one of the kind of perhaps one of the biggest topical points of water mist, and that's sustainability. So Dirk, we're going to stay with you, but also invite Robert in on this part of the panel discussion. So obviously it's an area of particular interest to both of you. So I'd like to pose a few questions here, invite you both to build on each other's insights. So Robert, I'm going to come to you first. From a research standpoint, how does water mist support sustainability goals in fire protection?
Well, I think Dirk mentioned it. With regards to the smaller amounts of water being used to extinguish the fires is the main thing that kind of shows that it's more environmental friendly. With less water that you need to put on the fire, you also have less wastewater from after extinguishment, as well as you can have a lot less pipes and materials with water mist systems. So both from the water standpoint as well as the components being used shows that you can decrease the carbon footprint by, I think, between at least 50%, up to 80%, depending on what you compare with. If it's an optimized sprinkler system, for example, or if it's conventional, where you just follow the standard when you install, then you see up to close to 80% decreasing carbon footprint on by using water mist systems.
And following on from that, Dirk, are you seeing increasing interest from certain sectors, like Robert mentioned, such as data centers or commercial real estate, for example? I know you mentioned data centers earlier in the introduction, but do you think these sectors are kind of driven by ESG criteria?
You're referring to me?
Sorry, yes.
If you got 2 Dirks. Right. Yes, absolutely. That's a big selling point right now. It's very important for our clients to gain ESG points by applying environmentally sound technologies and enhancing the sustainability. Sure, that's very good for them. I mean, now that the investment, they are doing, does not only comply with the requirements of the insurance companies, which is a financial aspect. It does not only comply with what the authorities require, but it gives you also a better standing with your banks or whoever would check on the ESG criteria. Absolutely.
And lastly, coming back to you, Robert, what do you think is some of the kind of other advantages that are perhaps undercommunicated or misunderstood in the broader industry, aside from potential sustainability benefits that we've already covered?
Well, I think with regards to water mist, it was quite developed and used in the marine industry for machinery spaces early on and confined spaces. So it was marketed that it's extremely effective in suffocating or choking the fire out. But by moving into their building industry, it's I think it's risen some misconception that water mist is not as effective for open and ventilated areas, and I think this is a misconception that really needs to be addressed. It's effective in a different way of cooling, and I think definitely.
And moving on to something you raised there in different types of applications. Obviously, battery energy storage systems are becoming a pressing safety challenge today. So Robert and Dirk, once again, promise your last questions, don't worry. I'm going to come to you again just to talk a little bit about how water mist can be used effectively to protect, obviously, lithium-ion batteries, and whether there's any progress that is being made in this area. So Dirk, I'll come to you first, and then Robert, I'll loop you back in.
Right. Yeah. So we have been involved in research work for batteries for the last 6-7 years, something like that, intensively. And I must say that really water mist is the ideal solution for energy storage systems. Yeah. Why is that the case? If you have a fire or, in the first place, a so-called thermal runaway in a battery system, in an energy storage system, lots and lots of gases are produced. Not necessarily a fire in the first place, but many gases. And these gases are highly explosive. Many people underestimate this risk by far. So that means if you have such a thermal runaway incident in an energy storage system, what you have to do in the first place is ventilate. And if you do that, then you cannot use any gas extinguishing system anymore. Yes, you cannot use any aerosol extinguishing system anymore. You must have something which constantly will be thrown into the room, kind of. And that the small droplets can do that ideally. Alternative may be a sprinkler system, but the sprinkler system also could deal with the ventilation, but it can not deal with electricity so well as water mist can do with its low water consumption. And it also creates a hell lot of contaminated water, especially in the context with batteries. So taking the ventilation requirement and taking the contamination aspect and the necessary cooling of the environment in an energy storage system, water mist is really just the ideal thing to use. Seriously, I mean, I'm a water mist promoter, no question about that. But from a technical point of view, we have done so much research on that, and we're looking for alternatives. But I cannot see any better solution for energy storage systems than water mist.
Definitely. And Robert, I'm going to loop you back in here. From a standards and research-based testing performance standards point of view, are these perhaps evolving to accommodate these types of applications?
Definitely, there's ongoing work on battery storage systems, and as Dirk described, we tested both high and low pressure water mist sprinkler and gas systems for these applications, and what we see is what Dirk mentioned: the accumulation of flammable gases. So if you use a gas system, it's quite effective in containing the fire in the spread between modules in a rack. But you need to ventilate at one point. And at some point in that phase, you will have a mix between oxygen and flammable gases that can and will most likely ignite. So what we saw is for water mist, you are very effective in cooling the entire room. So you also not just avoid spread between modules, but also keep the room and the integrity of the room intact with the water mist system. So it's a good solution. With regards to standardization, where of course, in the committees, both European and other standardization committees, working with both test protocols and so on for land-based applications, IMO, and also for battery storage systems, both on land and on ships.
Thank you. And I wanted to shift now to a more project and case study led section of the panel. So Markku, I'm going to come to you with obviously talking about a standout project that really caught kind of international protection and your work. Attention. Your work on the Notre Dame Cathedral is obviously a fascinating case. So I was wondering if you could walk us through how the project integrated water mist protection. Right? When did that begin?
Okay, actually the refurbishment planning started late 2019 after the fire that was in April 2019. And it took several months to assess the situation and what would be included in the refurbishment scope. One of the conclusions was that the rebuilding of the cathedral would require an effective fire protection against possible future fires. And that would include also passive and active solutions. And, knowing that water mist is one of the most effective firefighting technologies, that was included in the project by public tendering. And that's the way how we came into the project.
And what were the critical steps in moving, obviously, from this concept to the actual installation?
There were several steps prior to the fire protection tendering. INERIS, that is French National Institute for Industrial Environment and Risk, was selected to assess what kind of passive and fire protection solutions should be considered. And their selection of high-pressure water mist was based on understanding of its good cooling capability and low water consumption, and that is compared to low-pressure mist and traditional sprinkler systems. Marioff then, we participated in the public tender process starting in August 22nd, and finally the project was awarded to Marioff in March 23. One of the tender requirements was to perform a specific fire test program that was planned and organized by Ineris. That is very typical in these, let's say, very specific cases where water mist is required to protect some kind of building. In these tests, the simulated cathedral attic, because that was the case of the fire protection, the attic itself. The simulated attic was ignited and fire was let burn until it reached temperature of 1000 degrees centigrade after water mist system was activated. And then almost immediately the temperatures in different locations, they were measured in different locations, were dropped to the level of 50 degrees and water mist was pushing flames down. So these results were good and successful for the project, and then we continued. And based on these fire tests, Marioff was able to define the water flow rate and operating pressure of the nozzles, including nozzle spacing and location in the protected structure. That was a wooden structure of the attic. And this is a very typical way of working in the water mist industry with all fire testing. The project scope for Marioff was a turnkey delivery, including design, installation, and commissioning of full water mist system, but it also included aspirating fire detection system that is used to indicate fire for water mist system activation.
And just lastly, obviously you spoke how Marioff handled the installation process as well. Are water mist systems easier or different to install compared to a traditional sprinkler system, for example?
Well, not really. Of course, we are using a bit different pipe sizes than traditional sprinklers are using. Our pipe sizes are smaller, and we are using highly graded stainless steel piping. That is also one of the benefits of water mist systems because the piping will withstand very long. It has very long lifetime compared to normal steel structure pipes. But other than that, there is not really big differences. Of course, the operating pressure, 140 bar, requires that all the pipes and fittings will be pressure tested 1.5 times of the operating pressure. So the high pressure is also the difference there.
And I just wanted to ask an open question, out of curiosity to the panel. Obviously, you've mentioned obviously the Notre Dame case study, and I was interested to know if anybody else has noticed an uptake or an uptick in similar heritage-related inquiries or projects due to this kind of growing awareness with case studies like Notre Dame. So I don't know if anybody had any input there.
Well, we actually have. And of course, Notre Dame project is a significant landmark project for the water mist industry. And I think it's highlighting the fact that water mist has clear benefits in many of the applications, not only like this kind of heritage application, but eventually I think time will show how much this example will boost the market overall. I don't know about the others.
Yeah, I would definitely support this. Yes, we also see, but since many years, a lot of interest for heritage buildings and to protect wooden structures like our lightweight old constructions, everything what is old and what is has a certain aesthetic, which is looking nice, so to say.
Absolutely. And now turning our attention to the kind of standardizations and guidelines side of the discussion. Obviously, this plays a pivotal role in how water mist is adopted globally. So Dirk Laibach, I feel like I haven't heard from you for a very long time, so we're going to come to you. Can you share with us which guidelines are commonly applied to the EMEA region for water mist system design?
Yeah, for sure, I can. To be honest, it's a good question because we need to differ a little bit into the EMEA region and the other regions. Possibly we can come to this later on. In the EMEA region, let's call it a European region in general. It's a big field for water mist. So a number of installation Marco and Dirk already mentioned are in this region. It's a big market there. So that aims to the point that 20 years ago, a group of experts sits together and thought about we need to have guidelines, yes, for water mist. That was the start of, how can I say, creating a new guideline solely for water mist systems. Because as Dirk, Marco, and Robert already mentioned, they are a bit different than a sprinkler system. And also Marco and Dirk referred to fire tests. Yes, today's guidelines we have for sprinklers in place, they do not involve any fire testing. For water mist systems, this fire testing is required. It's mandatory to validate the effectiveness, and the correct layout, which Marco and Dirk already mentioned, is a result of the fire test. So that all was not existing. So today in 2025, we are in the happy situation that the European norm EN 4972, which is the European guideline to install, operate, and maintain and design a water mist system, incorporates all those massive fire testing procedures. That means the big part, the part one, is this guideline I mentioned. And then we have another 16 EN guidelines describing the fire tests for the certain applications water mist can be used for. So we are today in a good situation to have this EN norm in place, and this gives specifically guidance for planners, installers, consultants. They all can use it now. Yes, and so this is really a huge step ahead when we compare this. And everybody mentioned this, the technology around 30 years ago. It's not a new technology. What was missing out was one of those common guidelines applicable for the EMEA region. Yeah.
Thank you. And like you mentioned, we're going to come on to the rest of the world. So obviously the rest of the world, are there significantly different approaches, I suppose, to whether it's, North America, Asia Pacific, Middle East, for example?
To be honest, there are, yes. Most likely the Americans, they do not accept European guidelines. And that is the reason they have developed in the same sense, similar what the European did. They started about 5 to 10 years earlier. And this is the guideline from the National Fire Protection Association. That's the reason it's called NFPA, and the number is 750. Yes, so has also a good number. This guideline is, let me say, in coexistence to all the other guidelines we have for gas systems from the NFPA. But this is solely describing how to design, operate, install, and maintain a water mist system. In that sense, for looking to the fire testing, this guideline is accepting all, how can I say, acknowledged fire tests we have today in place from approval bodies like the German VDS or the American Factory Mutual or the British LPCB. So, but in a certain way, it's the same what the European standard is doing, but in the American way. But they do not describe the fire test. They accept them from the approval bodies as they are. But it is a requirement still there when you want to build a system in compliance to NFPA 750 that you need to maintain, let me say, the master document. You need to follow this guideline. And you have in second stage the fire testing from an approval body in place. Otherwise, this is still not compliant to the NFPA 750. So it's a certain way similar like in Europe. It's the same path forward, let me say like this, with a separated, how can I say, guideline document. This guideline, this NFPA 750, is very much acknowledged also in the Asia and Pacific region, and for sure for in Americas, not only North Americas. When we look to USA and Canada, it's also normally acknowledged in the southern part of America, makes Brazil and all those countries. Yes, and also in the New Zealand, Australia region, they all use normally the NFPA standard.
And my next question was going to be around third-party certification. So I appreciate you've just mentioned that. So I'll ask it anyway if there's anything you want to add to it. But to what extent can consultants and system designers rely on these guidelines alone? Or should they kind of be looking for additional manufacturer data as well as that third-party certification?
Yes, the third-party certification is not made by those guideline owners. Yes, it's not made by NFPA or the European norming CEN community. This is made normally by approval bodies, as I've already mentioned. It's from Factory Mutual or LPCB or VDS in Germany. So that is what those guidelines in a certain way require. So the one way is to design a system in accordance to the guidelines. The other things, those guidelines require also a certification, a listing and approval. Yes. And this is what you need to, how can I say, the manufacturers, we have 3 here in this audience, they need to go to the approval bodies, make those fire tests, need to test all their system components in compliance to the test procedures of the approval bodies. When you got that, you get a tick, you have an approval certificate, but still you need to maintain the EN guideline or the NFPA guideline regarding the design, installation, operation. What is different here in regards to all the other standard guidelines we have about conventional systems? Dirk mentioned them, gas systems, foam systems, sprinkler systems, that due to the fire testing we have here in place, certain parameters cannot be prescribed in any guideline. Imagine you make your fire test with your nozzle, whatever nozzle type it is, low pressure, hybrid system, whatever. And you want to know the distance between 2 nozzles, that your system works effectively as best as possible. That's what the manufacturer wants to do. This is the result of the fire test. Markku mentioned this as well. So this spacing, this distance between 2 nozzles, which is prescribed for a sprinkler system or for a gas system, is logically not prescribed in the NFPA 750 or the EN 4974, 97, sorry. It is, therefore, you need a called design book from the manufacturer, and this is called DIOM. It's called Design, Installation, Operation and Maintenance Manual. And those 2 guidelines always refer to the DIOM in the text, in the writing down, in the guideline. So in a certain way, you need to have at first the guideline. The guideline requires to make your component and system testing by an approval body. Yes. And secondly, thirdly, you need to have this DIOM from the manufacturer. It's normally owned by the manufacturer to make the proper design of your system.
Thank you. And just finally, obviously you mentioned, well, firstly, when you're talking about EN and NFPA standards, they sound quite comprehensive and we're in a good place, and that's great. But obviously you also mentioned that, 30 years ago, these standards weren't in place. So, it's fairly new when it comes to standards. So I'm interested to know whether you think that any of the guidelines require kind of further development, or whether this is kind of, whether there's some ambiguity around this, I suppose.
Oh, yes, they do. You see, specifically, those guidelines are compared to the others young. Yes, because the NFPA 13, for example, for sprinklers is existing since 80 years. So what is constantly done, all those guidelines have, let me say, the European has a work group around the guideline. And there are all those experts of consultants, insurers, manufacturers sitting in this work group and still developing more and more and more, and also receive from the field feedback. Maybe this one or other sentence can be written a bit more clearer. And this is continuous, how can I say, process to always look what we can do better in future. That takes place also with the NFPA 750. They have a specific technical committee, similar thing like we have in Europe, where all those experts sit in and they revise continuously also the NFPA 750 in certain editions. Yeah, so I think we started, let me say, 10 editions ago. Today we are 10 editions further. NFPA is a bit more smooth. They can work around those changes a bit faster. The SEN committee, when you want to make changes in those work groups, you discuss them, you have a special procedure. This can take easily 3 years to, how can I say, issue a new edition. In the NFPA, it's a bit faster. It's a more how can I say, quicker process. Yes, let me say it like this. But the SEN regulation, these are the SEN regulations. We have them everywhere in the world, and we need to follow them.
Perfect. And Robert, I also wanted to bring you in here from a standards perspective as well. Does RISE contribute to developments within the EN or any kind of other frameworks that would help address these issues? I say issues, not really issues, but changes and development.
Yeah, I think Dirk has summarized it very well. And with regards to the EN 14972 water mist standard with its test protocols, it's been a work in progress for 20 years until 2-3 years ago when they started publishing the test protocols. And RISE has been there from the beginning. And that being said, even though it's quite newly published, it contains test protocols that are well established in the industry and that were published originally, the first versions from the approval bodies. So it's been testing ongoing for the past 20 years, even though the standard has been released a few years back. Yeah, we're definitely trying to stay on top of the standardization work and making sure that the producers don't always get their opinion through, but they're doing a good job.
Yeah, I think one thing to add, Rob, you know this very well. Also, the approval bodies that are sitting in those work groups, yes, and they also improve their own test procedures. Yes, when you can imagine what Robert mentioned, some of those test procedures from the approval bodies have been issued 10, 15 years ago, and they made now hundreds of fire tests accordance to those test procedures, and they may have recognized a small improvement here is required and all that stuff. That happened also over the past 10, 15 years. The good thing is here, that's all now in this latest published EN norm, because this is the last version, yes, of all those test protocols. So it's a continuous process, and we are for sure not at the end. And I think in future for water mist, we see, I'm quite sure, another 20 new applications where test procedures will be developed for. And that's a great thing with water mist. Yes, the market is expanding all the time because more and more consultants, building owners, ship owners as well, what Markku mentioned, recognize that water mist is a really good technology with so many benefits, as Dirk already mentioned.
Absolutely, a great point there, Dirk. And also, it's not just the technology of water mist systems that is evolving and the applications, but also the environment we have. You know, you take a look at your house today, it's no longer just your timber frame or your your traditional bricks and mortar, there are so many different materials and chemicals that are now pose additional fire risks in buildings. So we'll no doubt start to see different applications where water mist might be more preferable to a traditional sprinkler or gas system like we've spoken about. So those guidelines, I'm sure, will continuously evolve, and no doubt, you guys will all be involved in that too. So it'll be exciting to see kind of where that goes. And just before we wrap up, I'd like to invite a brief kind of closing comment from each of you. So we'll go around the room again, starting with you, Markku, and with you, Robert. But what do you see as the most promising development or application area for water mist, whether it's now or in the next 5 years or so? So Markku, over to you.
Oh, I would say that water mist is already very well recognized in very many applications. That's the fact. However, I would say that the industrial application is something that water mist could do more. The industry really could benefit on water mist in many ways compared to competing technologies. Another thing that I would list here is that is the US building code that is currently preventing water mist to be in the market in US. So I don't know how we will do it, but we need to start lobbying in order to get water mist accepted in US market.
Thank you. And Sprakel, will come to you as well.
I personally really would like to see that water mist is even more used to keep up existing buildings. Yes, from a sustainability point of view, so that it really can give a great benefit to the society and to protect climate and so on. So that's what we have to gonna work on. And this energy sector thing with the batteries we were talking about before, that's another big thing. I mean, no question that the society needs this change in energy, and that means more energy storage systems. But we must make it safe, so people are not afraid to have these things in their cities and so on. And water mist really can help going this way, make it much safer.
Thank you. And Dirk, over to you.
Yeah, I think I can only follow and fully support Markku's and Dirk's points. Yes, to give you a good example for an industrial application is also that Factory Mute thought through, hey, we have the new technologies, and one of those are wind turbines. Yes, wouldn't it be sensible to look to make a test procedure for wind turbines? And they developed one about 4 or 5 years ago. It's more or less close to be finalized from FM. And these are the thoughts. Yes, there are a number of applications possibly we have in the future we can use water mist for. And I think there is no end of the story around water mist in looking to more and more applications. I fully agree with Dirk and Markku here. Yes, but wind turbines is just one example. Yes, or maybe in future when we see all those photovoltaic systems, and we still here and there hear that one of those can burn very much. Maybe that's another footprint for the future where we can apply water mist. We will see. Yes, I think it's not. The road is still open. Let me say it like this, and long. Yes, what we can use water mist for.
Absolutely. And Robert, lastly, we come to you.
Yeah, well, from a testing and research standpoint, I see the water mist industry also compared to gas foam and other industries as a very healthy industry. The producers contribute on standards, trying to standardize, and it's a lot based on testing of the performance of the systems, which give you hard data basically to make a decision if it's good enough, and not even or even outside of the fire testing, that there are standards for component testing and the whole system of around water mist extinguishment systems. So Yeah, I'm happy when I look at the water mist industry, and I think they're doing it right.
Fantastic. Well, thank you all for your time and your insights today. It's clear that water mist technology is not just an alternative to sprinklers. It's a very important system. It's dynamic and it's evolving, and obviously offers distinct environmental, technical, and architectural advantages that we've discussed here today. From preserving cultural landmarks like Notre Dame, so thank you, Markku, for that case study, and to enabling safer energy storage. And the future of water mist is, as Dirk says, unending. So I'm sure we'll see that developing soon. For our audience, we encourage you to connect with the International Water Mist Association, also register for their conference later in the year to discover more educational content and to stay informed about the ongoing development in this exciting field. So thank you all for your time.
Thank you.